Hello and welcome back to my scripting guide. In this series we extend our C++ application with a scripting language, currently Python. Yeah, last video we have already loaded Python and set up Python, downloaded Python and got ourselves up and running with Python, and in this video we are gonna start and use Python. So let's get started. So the first thing you need to do, even before you actually initialize Python, is you need to specify all that modules that are available for Python, so basically all your C++ modules. I already prepared these modules and they can be imported by calling pyimport underscore append init tab. This takes two parameters. First of all, a name. The name is CGL for console game lib. And it takes a function pointer to an init function. This init function is stored in pybind, pyimport, which basically is this init function to import. We're gonna take a look at this function in a few minutes. I'm gonna explain it to you what it is doing and how it is working. Alright, now that we have appended this init tab, we need to compile and load our Python module. This is actually quite nice, because in the first video, in the introduction video, I thought I'm not quite sure how compiling is all done in Python, and this was because I didn't find any examples directly on the Python site. But basically, if you are doing it like we gonna do it, you actually need to compile Python so that you can actually get these functions. And thus it's actually quite nice that we already see how things get compiled. And also because we see how it's get compiled, we can easily also experience how we would serialize that and could load that from disk. Alright, so basically what we are gonna do is we are gonna create a Python bytecode, and everything in Python is a Py object. So no matter if it is a bytecode, a module, a string, a Python object, whatever, everything is a Python object. So we're gonna say a Python object pointer, and we're gonna initialize this value. This is our pointer bytecode. This will be equal to py underscore compile string. Now we need to input a string, we need to input a file name, and we need to specify how we want to do this. The string, we're gonna load this from disk in a few seconds, but let's first start with the name. We're gonna call this hangman_script.py. This is just for error reporting and stuff. The last parameter needs to be file input, because we input a file to that compiler even though it is inputted as a string. But let's actually load that file first. So we're gonna load that load Python file. So what I'm gonna do is I'm gonna say handle h Python source is equal to create file. Yeah, it's actually, let's do file v. And we want a generic read on that file. We want a file shared read. No security attributes. We want to open an existing file. No attributes, so we could use file attribute normal if we want, and no template files. So yeah, that's everything we need for that file. Let's input the file name. This is in the current directory, and this will be called hangmanscript.py. Yeah, maybe let me format this a bit so that you can read this a bit easier. There we go. So now we open that file and we say if h Python source file is not equal to invalid invalid handle value, there we go, then we're gonna read file, and we're gonna also close handle. Here we're gonna close handle hi h Python source, so close file. And now we wanna first get the file size. So we're gonna have a divert file size, which is equal to get file size. So get file size is our hi h Python source, and no high size because it shouldn't be that big. And in case we have that file size, we're gonna allocate a memory pointer for that. Let's do a char pointer for that, which is our file buffer, which is equal to malloc file size plus 1 for the 0 terminator, and in case this file buffer is valid, we're gonna actually read this file here. Sorry. There we go, read file, and of course this needs to be casted to a char pointer. There we go. And now we need to actually read that file in case this memory is valid, and we also need to free memory valid. So there we go. We want to say free file buffer, and actually let me declare this file buffer a bit higher so that we can use it later on. So file buffer here, and this will be equal to that. There we go. And now we can say read file. This also means that this free file buffer. No, I changed my mind. I'm gonna get this down here again. Don't want to do this like that because we'll get some issues there. There we go. Now everything is good. Well, so we're gonna read this. So if read file, and we're gonna read from our Python source into our file buffer, and we're gonna read file size null, and in case this succeeded, we're gonna set our null terminator, which is on file buffer at file size, which is equal to our string terminator. So because the normal text file doesn't have a null terminator, we need to set this. And now we can compile Python code here. And let me actually move this upward, because this is our Python bytecode here, which starts at null pointer and now gets assigned in case all that file operation succeeded, is now equal to pycompile string here. So we're gonna copy this up here, and instead of these brackets, I'm gonna take in the file buffer here so that we compile this file buffer. Yeah, so now we have actually compiled. And in case this worked, then we're gonna load that module. So actually take the compiled bytecode and bring it to an object. So if pointer bytecode, then we're gonna do stuff. And of course, at the end, we're gonna free our bytecode. Now, when it gets to freeing stuff, what is coming from Python, so basically this pi objects are ref counted, but special things that you need to take into account for ref counting. There are functions which return a new reference, which you are responsible to dereference. There are actually functions that you give a Python object that steal your reference, so basically you don't need to call dereference. And there are functions that give you a borrowed reference, so basically in case you want to store this, you need to add reference to that. And yeah, that's just how Python works. So in this case, this compile string gives you a new reference that you need to free, and you free by calling Python decref, this macro here, on pointer bytecode. There we go. And this basically frees your Python, or not frees your Python object, but dereference the reference count. In case it hits 0, it will be freed. And important that we call this on the bytecode. So yeah, but now let's load the actual model. We need to actually import this model, which is done by PyImport. So we import a module into the Python runtime. So basically here we have compiled a Python module, and now we are importing this into the current runtime. I'm doing this by calling execute code module. So we're gonna execute a code module that will be then used in our Python thing here. We could call this hangman script, or we can just leave this blank. Maybe let me call this hangman script here. And we need a Python object here, which is our compiled object, which is our pointer bytecode. So this basically executes our code module. Actually, this also returns a Python object, but this Python object will be stored here by our Python objects here, and basically in the class. So we're gonna have a Py object pointer, which is our pointer, or my pointer module. My pointer, let's call it pi module, which starts at null pointer. So this is our Python module that we are executing here. So I'm saying my pointer pi module is equal to pi import execute code module. And in case this pi module is in existence, I am gonna extract all the functions that we're gonna need for running that. So basically our key event and our, what was the other function called? Our tick event. To actually store the functions, we need 2 more Python objects, because a function is a callable Python object, at least like, yeah, a function is a callable Python object. This is what you can see. It is definitely a callable Python object. So we're gonna have the tick function here. And we're gonna have another Python object, which is the myPointer key event function. It's just also equal to null pointer. So these objects are used to reference these functions. And now we're gonna get these functions here. So to get these functions, we're gonna say myPointer tick function is equal to pi object underscore get attribute string. This is a bit misleading because it's not giving you a string, or yeah, it is giving you an attribute of type string. So basically every function in a Python module is an attribute of the type string, or an attribute stored by a string identifier. So you give it an identifier and you get an attribute back, and this attribute is a Python object. In case you're looking for a function, this attribute will be a function. So basically if you would like to get some other attributes from that model, you can get this without any issues with the same function. So we want to say from our Python module we want to get our tick function here. Then we're gonna say our key event function pi object get attribute string myPointer pi module, and we're gonna get the key event function here. This basically gives us our 2 Python functions that we need for it. Now let's actually jump back to the uninit, because we first need to decrement refs here, because like every of these functions, and of course the module is a reference that we need to free. So in case we're gonna have this key function, we say pi decref myPointer key event function. And if we're gonna have a tick function, we're gonna say pi decrement ref myPointer tick function. And of course, if we got our Python module, I'm saying Python decref myPointer pi module. So basically everything we stored will be freed here. Now we can actually already try to run this, and yeah, we will get an issue there. Maybe let me we're gonna put my breakpoint here at the end of this function of the constructor. Let me run this and we're gonna see what happens. So you can see that we have finished this breakpoint, and you can definitely see that the module and the 2 functions are null. And well, this is actually true, because if you recall, we are looking for that hangmanscript.py, and currently, if I take a look at this debug folder, well, we have a hangmanscript.jar, we have a hangmanscript.lua, but no hangmanscript.py. So we need to make this available as soon as possible. So I'm going here to the Python directory. I'm gonna say add new object. I'm saying code, and maybe do some code, and I'm gonna call this hangmanscript.py. And you can already see that it has actually interpreted this as a Python document. Now you're gonna right click on that. You're gonna say that it is a content here, and as an element type you say it from not in build. You say to copy file and say okay, apply. Have I actually set this for all configurations? No, just release. So I'm doing this for all here and apply. Okay, quite similar to Lua. Did I actually? Yeah, on Lua it was for all configuration. It's good. Like the same on Lua here, but with Pi now. But yeah, let's now start writing something here, because we need to define the function. So we're gonna say define our tick function here, which is just gonna pass here. Or no, basically the tick function needs to return something. So let's just return false here. Then we're gonna have, why do you have these issues here? Yeah, because I need some brackets there. There we go. Should be good. Yeah, now we're good. Then we have the key event function, which takes a key. and this will just pass because we're not gonna have some code in there for now. So basically we have now defined some functions, maybe do some documentation called when the user presses a key, and our tick function called every second. There you go. Now we have our hangman script. Now let me actually build this, and we should get a copy of that hangman script. Let me quickly verify this, and you can see there we have it, hangman script.py, which is a Python source file, and you can see, yeah, it's looking quite good. And let's actually now try out what the application is now doing. So I'm gonna press E here, hit the breakpoint, and now if we take a look at our object here, you can see that the Python module has been initialized to a actual proper pointer, and both functions have been set to a proper pointer, and this actually means that we are good and up and running. So yeah, now we can continue execution, and it will just fail here because, well, the functions here are not implemented. So let's start by implementing them. We're gonna start with the tick function because tick is a bit easier, because we don't have to take any return values into we don't have to take any arguments into account, just the return value. So we're gonna have our Boolean result, which is by default false, and I'm gonna return my result. So gonna say return final result here, and now in the body I'm gonna do this only if function is available. I'm gonna say if my pointer tick function, then I'm gonna say py object call object, and basically by calling this py object call object function, we are gonna call the default function of a callable Python object. So basically, as I told you, when we get this attribute, we get a callable Python object back, which is basically a function, because a function, a static function, is a callable Python object. So I can just say py object call object, which calls a normal Python object. So in this case, this is my tick function here, and there are some arguments. Because we don't have any arguments, we just input the null pointer here, and you can see that this is returning a Python object. So I say py object pointer, which is the pointer result, which is basically the call result of the function. So basically we say call Python. There we go. Now, very important, this is something different. There are actually several functions. You can actually say call method. Basically, calling a method is calling a method on an object, which basically takes an object, a name of the method, and a format and some arguments. This is just like calling a function on an object. And there is also a function called call, we have it py object, call function here, which calls a function with a format on a callable, but we have used this call object because this is a callable object. It's a bit some differences between methods, an object associated, and functions, which is a static function in a class. And with the call object here, we actually call like the raw callable object the most easiest way. If you're gonna do some more stuff in Python, you may want to take a look at the other ones as well. So yeah, something very important is that we got this pointer result. So only if we get this pointer result, we can actually extract something from Python. And we also need to make sure which type this is. So we're gonna say py bool, which stands for Python Boolean, and there is a function called check with that py Boolean, and this check, actually it's a macro. If you input your result here, it's gonna check if this is actually a Boolean that was returned. If you take a look at here, it's actually going to this py is type with x and a pointer to the py bool type, and py is type basically calls another function here, which does some const casting and internally checks the type fields of that object and checks if they are valid. Actually, we could actually try and trace this down here, this function. Can actually see this is a static inline here, py is type, and it's checking if this from the py object, the parameter ob type, which is defining the type, is equal to the type here. Basically, we could also like do something like that, pointer result ob type is equal to py type bool. Where did we have it? Or py bool type, yeah, py bool type dot ob type, where is it? type somewhere, but somewhere this is inside this pybool type. There would be this field. So basically, this is checking the same stuff here, or is it actually already? Is this a pybool type? Could also be that this is already. No, it's again a py object. So yeah, okay. Py type object, okay. So basically this is just checking here these things, but we won't go into a bit of a detail. So now you would expect something like pybool, as boolean or to boolean, but basically this is not working. On Python, every object has a function or has a Boolean converter. So basically I can to every Python object say Python object is true, which basically checks if the Python object is true. And in case of a boolean, this just returns the state of the boolean. So if I say Python object is true and assign this to our result, we basically extract the is true, the current state of the boolean. So it is very easy to do this like that, basically just saying result is equal to py object is true. It's a bit here mix matching of two types. Pybool is doing the checking and py object is true is actually giving you the data, but basically also like every py object has a toString. So we have a s where we have it we have a Python schar buffer. No, where was it? Here, py object string. Every Python object has a string function which generates a string out of that object. So basically it generates another Python object which would then be of type string. And this is kind of like the same. Every Python object has this is true parameter assigned with it. So yeah, let's actually test this and press F5 and see what's happening. Maybe let's, we're gonna make a breakpoint here somehow. Let's actually check if everything is working. But I'm gonna take a breakpoint here so they can actually see that there's something going on here. So are we hitting the breakpoint? Yes, we are hitting this breakpoint. So you can see that the pointer result is an equal Python object here. And we also extract the is true here and then returning the state is true. We can actually easily verify if this is working by open our hangman script. Currently tick is returning false, so in case I start this and press E, this should straight away close. There we go. And in case I replace this with true and press F5, you're gonna see that, let me zoom in, and I press E, it will stay open. I could wait just a bit, and you can see previously it already closed, basically because this tick function is always returning true. So now that we have verified this tick function, now let's actually start and write our key event function. So yeah, basically this will only work if our key event function is possible, of course. So only if function is available. But actually, I forgot something. We also need to free this Python result here. This will memory leak. Py object call object will return a new reference here. So we need to free this. So actually, let me maybe extract this out of here and I say if that, then we're gonna move that in here, and here we're gonna say pydecref for pointer result. So there we go. Decref here. Okay, now let's go back up here. So to actually call Python functions that take arguments, you need to understand what arguments are. And arguments in Python are actual tuples. So actually every function that is called in Python is called, every function that is called in Python and has arguments is called by a tuple. So basically all your arguments are packed into a tuple. This is easily doable. We just need to create this tuple. So there are functions for tuples, and tuples are just py objects. So I'm gonna have my pointer args for arguments, and these arguments are equal to py tuple pack. The py tuple pack function is a variadic function which can take an arbitrary amount of input values, and it will pack them all together in one tuple. Only thing you need to take into account is the first parameter. That is actually the count of objects. So currently this key event just takes one argument, so I'm just putting 1 in there, and now I can put in several Python objects. So now you will think, why can you do this like variadic? Because if you would like do something like py object new here to create a new object, then you would memory leak at some point because you are not decrementing the local reference. And this would be true if the Python pack and also the Python tuple set element or set or item were not stealing references. So basically this PyTuple pack function is stealing references. Basically how this is working, it's creating a tuple of a size, and then it is inserting several items, and every insert method is stealing the reference. So the whole PyTuple pack function is also stealing references. And so we are good to just initialize these objects here in line, and we don't need to free any references. So how do we actually input a char? Basically, Python, the same as Lua, does not support char types. But it has a nice function that can initialize a string from a pointer to a char and the size. So basically non-null terminated strings. So this is very good because this means that we can actually call this function and don't need to convert this into an array first. So we can say Python string, no, because Python string is not available. It's called Python Unicode because Python uses Unicode strings. So we say Python Unicode and we say from ASCII. And you can actually already see that this function is actually starting with an underscore because this function is actually not mean to be called from the C interface because it is a bit unsafe, because you need to make sure that these are 100% surely ASCII characters, and you must also check that the size is correctly. So basically they have a function called Py Unicode from string, which is basically taking a const char pointer there. But because we are actually certainly sure what's going on there, we can actually take this from ASCII here without any issues, and we can just import a pointer to our key and a size of 1, which basically just packs into this arguments one object here. So we're gonna pack arguments. Even through we are just having one argument. In the case this pack actually succeeds, we will continue on and do our call. But we need to, of course, decrement the ref count here some way. So py-ref, before I'm forgetting that again, pointer args will decrement the reference count of that specific Python object here. So yeah. Now we need to call a function again. This is the same as we did before here. So py object call object. We're gonna need an object here, which is our pointer key event function. Where is it? Key event function. There we go. And we need some arguments, which are our pointer arguments, and we will maybe retrieve something here. So I'm gonna just say py object pointer result. Even through this result pointer should never be present, but in case somebody returns something, I want to make 100% sure that I don't leak something and just call py-ref here anyways, even if we're not gonna process this result. But in case somebody do return something, I want to make sure that I decrement some ref counting on there, so just to be 100% safe there. Alright, now let's jump back to our Hangman script, and I'm gonna do another variable here. So keep running, the whole famous keep running, which is equal to true. No true is caps in Python, and I'm just returning that here. And I'm gonna check if key is equal to x. I'm gonna say keep running is false. So basically I'm gonna uncheck this keep running here, and this should be good. And let's see if it is working. I hope so. So I'm gonna say the Python implementation, and this should now stay open. As you can see, yeah, it's not closing. This is good. And I'm gonna just wait a few more seconds here, and now I'm gonna press X, and it is not closing. That is not good. Alright, adding the global keyword everywhere. I think this is not totally required here, but adding the global keyword here to keep running and here the key event did fix the issue. Yeah, it's not 100% clean, but at least it's like kind of like working. I mean, you could actually, especially with Python and PyObjects, it's actually quite similar to Java and C# to actually do OOP. But since I actually wanted to show how easy you can go with Python and scripts, I wanted to show this approach. But yeah, actually I don't know why, but yeah, this keep running is not working here in the scope, even though it should be considered as global. Now I've also added our random word here so that we see all of our joy that is going on here. So let me actually say Python implementation, the word is vision. And in case I press X, we should exit there. Let's try again. Zoom in, press E. The word is booked, and press X, and we exited. So basically Python did work the same way as we expected it to work. So there is actually everything right here. Yeah, I mean, it's a bit unclean with that global. I'm not totally happy with that. I'm gonna may try to fix an issue, find an issue for that. But basically the best way would be to actually also go like with object orientating, because Python is more OOP in this case is some other programming languages. It's kind of like a hybrid OOP. It's not totally OOP because like everything is a Python object, and yeah, it's not 100% object orientated. It's kind of like object orientated, but it's not object orientated. So basically things that go in Lua doesn't go here, and things that go in Python doesn't go in Lua. Yeah, but basically this is how you would embed that Python stuff here. Now, I promised you that we are gonna talk about the binding. So basically this PyImport append in a tab. This actually appends a function to a import table associated with CGL. So basically in our hangmanscript.py, we've imported CGL, which basically take a look at this import table and found that for CGL this function is responsible. Now if you take a look at this function is defining all the modules here that are loaded. So basically this is returning PyModule create, which creates a Python module, and it creates this from that module description. Basically this has an head, which is just initialized by default value. It has a name, which is CGL, and a description, which is the console game lib here. Then it takes a size, which is just -1. We may go into that maybe in another video, but you could also like search this up. I don't think that I'm gonna do more in-depth tutorials on embedding, but maybe if you wish. So yeah, basically this is just a more parameter here defining this Python module, and you're gonna have some pointer to a table of bind methods, which is this table up here. So basically this create loads this descriptor, which loads this table, which defines every single function inside your module. So basically how this works is actually quite simple. You have an array here, and the array is terminated with a entry which just contains 0, an entry which is just returns 0, and all other entries are defining functions. So basically you have a function get random word, clear buffer, presend, and put string. They are all redirecting to other C++ functions. We're gonna take a look at them in a minute. They are having attributes. In this case, we're gonna have math var args, which just says they have variable arguments. Just put this in there. I mean, yeah, I think you could actually also say no args at some of them because they don't have any args. I haven't tried this out if this works, but basically this is just a hint for Python. You can actually say no args. This would work. I can actually try this out here. Because like this get random word is taking no arguments, present and clear is also not taking arguments. I think we should also be good with that. Let's just try this out if this also works. There we go. Python. The word is lel. Yeah, still working. We got every function tested here. So we can say no args at them, which is a bit cleaner and more defining. I just had an issue where I temporarily removed this with var args. So yeah, but it's working with no args anyways. So okay, now let's take actually a look at these functions, how they are implemented. So basically on Python, this is actually already wrong what I'm showing here. Actually, Python methods always need to have a special syntax. They always need to return a Python object which is not allowed to be null pointer. And they're gonna take in an object as a Py object and arguments as a Py object. Basically, this object is just the object on which this was called. In case this is like static, it will just be null. And the arguments are the arguments passed by the user, which can be null, and it returns a Py object, which is not allowed to be null if you are returning nothing. This needs to be Py none. equal to pi none, which is basically just a pointer to pi none struct, which is basically a constant defined struct which represents the Python none. But it can't be null pointer. In case you have null pointer, you will get some issues that you can't resolve. So basically you will get an assertion error without having some assertion text available in case you don't, if you actually do link against the debugging libraries and add the debugging libraries in Visual Studio and add your source part of your Python. So basically if you go to GitHub and download the Python source, and if you downloaded the debugging libraries, you can link them in the Visual Studio and actually get the texts there. But basically if you are just returning null pointer there, you will get some unsatisfying errors that don't show you what's actually going on there. So make sure to always return pi none and not null pointer. So yeah, what I'm doing here is I'm just getting my random word and I'm saying my random word object here is equal to pi Unicode from string, which basically is creating a new Python object, and we don't need to release some reference to that because we are returning this to Python, and then Python is handling all the reference with that. So basically by returning we are giving over the reference and giving Python this new reference we have created. Now, clear buffer and present is straightforward. You just call this function. Put string is a bit more involved. First of all, I'm gonna get the size of the tuple from the arguments, because arguments are tuples. I'm just getting the size, and the size needs equal to be 3 or 4. So basically we need at least x, y, and a string. And optionally, if we have 4 arguments, this Boolean wrapping. Next thing what I'm gonna do is I'm extracting these Python objects. So basically I'm saying arg0, arg1, arg2 are equal to Python tuple get item, which is getting an item from the tuple. Very important, this is creating no new reference, so you don't need to free these reference, you don't need to decrement ref count. You actually borrow this reference count. It is not stolen and it is not newly created, and you just borrow this for your current function. So in case you want to store this for later, you need to add a reference count and store this. And in case you actually don't want to do this, you need to make sure that you don't call decref. Alright. Next thing I'm going to do is I'm checking if all these arguments are valid, and I'm checking if it is a long. So basically I'm checking if argument 0 is a long, which basically means it's an integer. I'm checking this for arg0 and to arg1, and for the second arg I'm checking if this is a Unicode. So be sure that this is actually a string, and in case I have this extracted, I can easily get all these data. So I'm saying long x is equal to Python long as long arg0 and as long arg1, which is extracting the actual long value. And I'm also getting a constant char pointer to this Unicode string, and I'm getting this as UTF-8, so as a const char pointer. Alright, next thing I'm checking is if x and y are bigger equals 0, just to check my bounds because my function is just taking unsigned here. And then I'm gonna default my wrap to false, and if the argument sizes are 4, I'm gonna try to extract a third argument or a fourth argument, argument 3, from the tuple. I'm gonna check if this is valid, and then I'm gonna check if this is a Boolean. In the case this is the case, I'm gonna override wrap to pi object is true, which we already used, which basically gives me the value of a Boolean variable. After that, I can easily just call my console put string with x, y, string, and wrap. And then I, of course, return none because this function does not return anything. Alright. So this was Python. We have successfully included Python in our project without any issues, without any hazards. Worked quite well. Okay, not without hazards, because we had to have this global attribute there, which is a trap. Basically, it's most important to have this at the functions available, so it doesn't place them here in this local scope. So just putting global here would be enough. I could easily just delete this, but I'm going to add this here just for convenience. Alright, so thank you for watching. We're gonna see us in the next video where we get to the last scripting language, Angelscript, which is probably a scripting language nobody of you have ever heard of. So yeah, stay tuned and have a nice day. Bye!